Class, we will begin with introducing safety briefing and house rules. After that, I will introduce myself and the class. I will request everybody in the class to introduce themselves. Then I'll tell you what is the today's topic. Then we'll start discussion on the topics. After giving the brief of the topic, then I will explain the topic in detail, all components of the topics. And then we'll discuss in the end what we all have learned. Is kind of refreshing. And finally, there will be self-assessment quiz. And you will be able to give your feedback also. All right. So this will be the today's course content. All right. Let's proceed. Safety briefing. Wherever you are, wherever you're having this course, attending this course, if in a classroom, this course was actually presented in a classroom. So that's why I have made these exit routes. So you must know the exit routes from the class. In case of an emergency, you should be able to exit safely. When emergency alarm is sounded, gather at the designated muster point and wait for the instruction. Most of our classrooms, we always have introduced like what are the emergency alarms system, and like we do on the shift. And so those are the standard alarms which we all must know. So what is the alarm in your academy? You must know before you start the class. All right. Roles and responsibilities. Some in every academy, people are assigned different duties. So everyone must know what are your emergency duties and how to proceed and follow your how to follow and how to reach your respective muster stations. All right. House rules. Check that you have a notebook and a pen available to you to take notes as required. Like in any class, you will be making some notes. The important points you will be noting down. So it's important to have a notebook and a pen with you always. Avoid any kind of distraction like cell phones, etc. Put them on silent mode. In case it's an emergency and you have to attend the call, request for the permission, you can go out and attend to the phone call. But I prefer that you don't. Uh, if it is not an important call, you can just leave it aside, and attend to it after the class or in the break time. So as I said, please put your mobile phone on the silent mode. We expect your full attention throughout the duration of the course, this session. Speak up or raise your hand if you want to ask any question, need any clarification, or want it to be explained again. All right. Your participation in the class will make it mutually beneficial for you as well as for myself, the teacher. All right. This is about myself. Today, I'm Sanjeev Mehta. You may call it Sanjeev. I hold a bachelor's of engineering, followed with a specialized training in marine engineering. I also hold a class 1 motor chief engineer license to work on ocean-going ships with unlimited horsepower. I'm an, of course, ex-chief engineer with 21 years of sea-going experience. Trust me, I miss my sea life. Teaching and training for further 20 years, 22 years, you can say, maybe more actually now. I wouldn't have known the joy of mentoring it if I had not quit the sea life. This is another side of the life. I am enjoying my training times also. Now I will request every one of you to introduce yourself. All right. Okay. Now we'll go ahead. Today's topic: common components in refrigeration and air conditioning system. So, what are the common components and what they are? We'll talk about them and discuss the importance of each component, how it fits in the system, how the refrigeration and air conditioning system works. Remember, this is only a basic introduction to the course. There are many more things to learn about refrigeration and air conditioning. We learn them as we go ahead. Different topic, different sessions I will be conducting. So this is the first of the session in the refrigeration and air conditioning module. So you know basics of you heard about refrigeration, and you also must be using air conditioning, right? So let us see how much you know about that. Okay, common components. After the end of today's session or lesson, you should be able to understand and identify the components common to refrigeration and air conditioning system. What are the common components in both? Understand the refrigeration cycle, air, air conditioning also. The basic cycle is is a actually refrigeration cycle. Okay, all right. The cycle is called refrigeration cycle, whether it's the air conditioning or refrigeration. You can call it air conditioning cycle also, but basically it's a refrigeration cycle with different temperature requirements of the two systems. Yes, temperature requirements are different. Refrigerators are kept at very much lower temperature than the air conditioning. Air conditioning is for comfort, and refrigeration is for the prevention to put your food items so that they last longer time. How the same component work equally good and achieve the desired result. That means having the different temperature requirements of air conditioning and refrigeration, same components actually work equally good, whether it's refrigeration or air conditioning. All right, so that we learn how the two different temperatures are maintained. All right, brief explanation of component to understand why they are needed, how they are common for both the system. All okay, because components are more or less same. So why they are needed, and how they are common for both the system. How do we know when the system is abnormal? If there's some abnormality occurs, like kind of troubleshooting. And in that, a small quiz just for you to assess how much you have learned. Okay. Again, I repeat, I always say learning has to be a joyful experience. To enjoy it and learn. Common components: refrigeration and air conditioning. Number one, first come the compressor. Is the workhorse. It is the compressor because it is doing the work. The actual work is done by the compressor. Without the compressor being in the system, uh, no work will be done and we will not be able to achieve our desired results. We'll see what do I mean by compressor? What do I mean by the workhorse? Condenser. Condenser, as the name implies, is condenses. What does it condenses? We'll see that. Receiver, the storage time. After the condenser, some of the system you will have a receiver, some of the system you may not have a receiver. The system will work equally good without a receiver also, but depend on the in the system how it is designed, and most refrigeration or air conditioning system or refrigeration system you will have a receiver also. Then the come expansion valve. What is the function of expansion valve? Because it is without the expansion valve, the desired effect of the refrigerator gases actually which we are using will not be felt, cannot occur. What is the evaporator? It absorbs. What does it absorb? It absorbs actually the heat. Yeah? So condenser, which I said dissipate, the heat absorbed in the condenser evaporator is dissipated in the condenser. Hmm. Six, the refrigerant, which makes it happen. Without the refrigerant, the cycle cannot be completed. Cycle will not work. Hmm. So all these six components are required. Or you can say number three can can be combined with condenser, or two and three can do the function of condenser. That means do the function of receiver also. Okay. Any questions? Components. We just saw a list of components which are essential for the working of the refrigeration air conditioning system. Study of these components will make participants understand why the common components are there and also the purpose of the component. So each of the six components which I have narrated, we will go one by one, discuss. I will explain what they are, what is the function of the of this these components, what work they do, how they are essential, and how they are related to each other. Hmm. All right. Other than the above mentioned component, there are various valves, compound gauges, solenoid valves, lubricating oil pumps, refrigeration gas, and lube oil charging points, dryer, etc. These we will learn as we go further in the session. In different modules, I'll be covering these parts also. But in this topic, today's topic, we will restrict ourselves to understanding only the major component which I have listed on the last page. That was the six of the components only we will discuss. Okay. Common component. Refrigeration and air conditioning. Physical components of the system. We are discussing compressor, two condenser, three restriction or expansion valve, four evaporator. All right. Here, what we have not mentioned, receiver. Is for simplicity because receiver is actually part of the condenser. Hmm. So, so what and gas refrigerant I have not shown because refrigerant is in the system. So it's a gas. Really, I cannot show separately. So gas is in number one, number two, number three, number four. All of them contain the refrigeration gas, but in the different form. At one time it will be in gaseous form, and other time it will be in liquid form. Okay. So restriction is expansion valve or thermostatic expansion valve. As I said, simplicity, receiver is not shown here, which comes after the condenser. Now let us discuss the function of these components. Now I will start first with the refrigerant. Hmm. Because without refrigerant, system will not work. Actually, without any of the component, system will not work. But a refrigerant gas makes it happen. So we must know what is the refrigerant gas before we begin. So although refrigerant was not part of the component showed on the previous page, because I said it is in the system, so cannot be seen as such. Nevertheless, it is most important of all. Both systems use the refrigerant gas or refrigerant for achieving the specific temperature. So why do we use a refrigerant? And what is a refrigerant? Actually speaking, what is the thermodynamics law? Thermodynamics law says heat will flow from a higher temperature zone to a lower temperature zone. Correct. And what is the function of an air conditioning or refrigeration? Both cases, the compartment which is refrigerated or compartment which is being air conditioned, the heat from that area is taken out and thrown outside to the ambient and to the environment. Environment is hotter than the compartment which is being refrigerated or which is being air conditioned. So in this case, heat has to be rejected. But the thermodynamic law says natural heat flow is from a higher to a lower temperature. In this case, heat we are taking from lower to a higher temperature. So we need a refrigerant. To achieve this, we need a refrigerant, first thing. So we need a medium which has certain qualities to help us achieve our goals. And work has to be done because this is we are going against the laws of the nature, uh, laws of the physics, you can say, not the nature, laws of the physics. So some work has to be done. This work will be done by the compressor because heat will flow naturally. But now you want to take the heat and reject it against the natural phenomena, natural physics phenomena. That means work has to be done. For that, we need a compressor. And to carry the heat away, we need a refrigerant. Understood? To carry the heat away, we need a medium, which is a refrigerant. And since work has to be done, that work will be done by the compressor. So I'm showing the refrigerant here first because the refrigerant as a component was not shown because it's a gas. It is in the within the system. So the what should be the properties of the refrigerant? Refrigerant should be non-corrosive, non-toxic, non-flammable, with no ozone depletion and zero global warming potential. Actually, for safety reasons and to protect the crew life or human who are present for which air conditioning is being used, or the food products are kept in the refrigerator. Since the global warming is an issue, and ozone layer protects us from the infrared rays of the sun, ultraviolet rays of the sun. So ozone depletion substances are also should not be used, and they are being phased out. So these should be the properties. And other thing, it also need to have boiling point which is somewhat below the target temperature. So what is the target temperature in a refrigerator? In a refrigerator compartment, it is around +2 or +4 degrees centigrade, sometimes +6 also. And in the freezer compartment is -22, maybe below, but normally -20, -22 is kept. So to achieve the targeted temperature, refrigerant must boil and evaporate below the desired temperature because refrigerant enter into the compartment which is being refrigerated or being cooled as a liquid. Now that what if the target temperature is -22, it must evaporate at this temperature. So otherwise, if we then only it will be able to bring the temperature to the its evaporation temperature. In fact, it should evaporate below also. Correct? No. So it must have a high heat of vaporization and high critical temperature. More the amount of heat carried away during evaporation, more the efficiency of the system. So the amount of heat which is being rejected, if it is capable of carrying larger amount of heat, better the efficiency. And what is the critical temperature? Critical temperature is that temperature above which a gas cannot be liquefied, no matter how high is the pressure. So naturally, the critical temperature must must be uh, above must be much above with which above which a gas cannot be liquefied. If let's say critical temperature is -10, for example, so this refrigerant cannot be liquefied. If it cannot be liquefied, the refrigerant effect cannot be achieved. So it can never bring the temperature -22. All right. So we cannot use it. So refrigerant has to have a critical temperature much lower refrigerant. So now newer refrigerants are being developed, R404A, R134A, and others. Hmm. And with R32 and R290 and R1234YF is being used in the car, which is almost inflammable. CO2 and ammonia had also been used in the past. But since CO2 critical temperature is 32 degrees centigrade, eh, so it is actually not very, which is very ideal for refrigeration system because if the temperature is 32 and above, it cannot be liquefied. So it cannot carry out the function of air conditioning and refrigeration. Correct? Boiling temperature of other refrigerant, just for a year information, R32 -52, R34 minus 26. CO2 is minus 78.5. So R32 minus 52. We don't need freezer temperature below 22 or 23. So R34A is also good for us, which is 32 or 134A are the most common one, which are in use now. Come to the compressor, number one item which had mentioned, common component compressor, the workhorse. Since we work against the laws of the thermodynamics, that means the laws of the physics, that heat is from the compartment, refrigerator compartment or the air conditioning compartment. Heat has to be absorbed here, which is low heat area, and discharge exhausted outside ambient temperature, which is higher. Summertime, outside temperature is more high. That's why we need to lower the temperature of our house. And in a refrigerator, always outside temperature is higher than the temperature inside the refrigerator. So heat has to be absorbed from the refrigerator or from the air conditioning area. It has to be rejected into the ambient, uh, or what we call uh, outside area, environmental area. So heat has to flow from low heat area to high heat area. So some work has to be done. This work is done by the compressor. It is not a pump. Actually, it is not a pump. But for the purpose of understanding, it can be set to pump heat from a low temperature to high temperature area. So in a way, we can say that heat is being pumped out from low heat area to high heat area. So it's taking suction from low heat area, which is heat. Heat is being sucked out and being pumped out to the outside area. So what the compressor does? Compressor pressurizes refrigerant and making it easier to condense it. Why does it make it easier to condense? Hmm? Remember Boyle's law and Charles' law? At higher pressures, the boiling temperature, also the what you call melting temperature, hmm, or condensing temperature, or it will become liquefied. That become that becomes low. Let's say liquid, or let's say a gas, which a normal condensing temperature is, let's say, minus 50, for example, minus 50. If you make the pressure of the gas very, very high, so it will become liquid at a lower temperature than minus 50 or higher temperature, at high temperature. And if you reduce the pressure of the gas, hmm, it will start boiling at low temperature. Correct? No. That's why in the freshwater generator, seawater boils at 45 degrees centigrade, 47 degrees centigrade. Otherwise, boiling temperature of water is how much? 100. Because we create the low vacuum there. We create the vacuum there. Now, if you increase the pressure and make the pressure high, eh, let's say 20 degree, 20 kg per centimeter square, will the water boil at 40 degrees centigrade? No, it will not even boil at 100 degrees centigrade. It will boil at much higher temperature. And will be, if it is a steam, it will become water at much higher temperature. So that is what is done here. So gas refrigerant is compressed and pressure is increased, so it becomes liquid at the room temperature, which is, let's say, outside temperature, let's say 40 degree in summertime in India, countries like India, or 30 degrees like countries in the United States. Okay, so it will condense. That is why we compresses the gas to raise the pressure. Hmm. So you read Boyle's law and Charles' law, also Gale-Stokes law and combined gas law to, uh, if you want to understand further the functioning of the gases, how the gas acts and behaves in physics. All right. Condenser. What is a condenser? As the name implies, it condenses. But condensing, what is the effect of condensing? So the gas refrigerant is is a higher pressure enter in the condenser at a higher pressure because the compressor has increased the pressure. So it condenses refrigerant which is at a higher pressure and higher temperature also. Pressure increases, temperature also increases. So it takes heat away from the refrigerant and rejects at the ambient temperature. Now this, because the high temperature of the refrigerant, it is rejected in the condenser. Here, because of the higher pressure, it becomes liquid. And when it becomes liquid, this heat is being taken away from the refrigerant, which actually had brought from the room which was being cooled. Also, because the heat was given by the compressor, because work done got converted into the heat. So this heat is given away in the condenser. Hmm. So heat is taken away by the seawater generally on the ships, which is seawater flowing through the tubes, or by sometime through blowing the air, ambient air in shore establishment or in your refrigerator or your air conditioning at home. So heat is rejected. So that means it dissipates the heat. Where does it dissipate? It dissipates the heat to the atmosphere. Heat removed while liquefying vapors is then rejected in the condenser. So refrigerant vapors are being condensed, becoming liquid, and also rejecting the heat which it had carried, which had brought from the room which was being cooled or a refrigerated area, and it dissipated in the ocean or the atmosphere. On ship, condenser is cooled by the seawater, and heat is taken away by the seawater and rejected into the ocean. And the fan blows ambient air over the hot condensing coil ashore in the shore establishment. This cools and condenses the refrigerator, but heats up the air blown away over the condenser. Also, fresh water can also be used in industrial, when your, let's say, large buildings have to be cooled. That's why we have cooling tower where this water actually then is is falling down from the top, and it becomes cooled down, and again it enters into the condenser to 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 liquefy the refrigerant gases. This actually comes after condenser. It's kind of a storage tank. It acts as a storage tank and surge tank for liquid. Suddenly, when the demand increases, the gas from there, if will flow out from there. If the demand is less, liquid will remain stored there. That's the only purpose of it, nothing else. So without receiver, also system can work. So receiver also acts as a kind of vapor seal, keeping refrigerant vapors above the liquid refrigerant in the receiver. Hmm. What does it mean? So there is the liquid from the condenser comes to the receiver. Whenever there is liquid present, vapors will also be present until the whole compartment is fully uh, filled up with the liquid. So receiver will have some level, and there will be some area where there will not be liquid. So in that area will be filled up with the, you can say, refrigerant vapors. So it can act a kind of vapor seal. Now the vapor cannot go to the your expansion valve. Only liquid will go. So the receiver is acting like a vapor seal. So it's sealing the vapor. If loss of refrigerant occurs, after identifying the leakage point and rectifying, liquid refrigerant can be charged in the outlet line of the receiver. after closing the receiver outlet valve. So, in this is also a possibility. eh. Sometimes liquid refrigerant does leak does occur. So you need to recharge the system. So recharge system is done in the receiver. This charging is different method. I'll be covering in a different topic. Primary purpose of receiver is to ensure no vapor moves down in the liquid refrigerant line, because now when the system will work, air conditioning or refrigeration system will work only if the liquid passes now onwards to the expansion valve. What is expansion valve? I'll explain in a while. So primary purpose of receiver is to ensure no vapor moves down in the liquid refrigerant line inlet to expansion valve. It also has a side glass for checking the level of refrigerant. So you can check that what is the level. If the level is coming down or cannot be seen, then if required, you can charge some more refrigerant into the system. Okay. Now, expansion valve number 4. This is what actually all components are essential, but this is the component which actually makes the refrigerant work and take the heat away from the system. How? Because now refrigerant is still at a high pressure. Before the expansion valve, refrigerant is at high pressure. All the liquefied from the compressor, it was the gaseous form at a high pressure. When it enters condenser, it's in vapor form, gaseous form, high pressure. After the condenser, it is no more gaseous form, it is liquid form but high pressure. Hmm. Now, now this pressure has to be reduced before it enters the evaporator, and the pressure reduced by the expansion valve or restriction. If high pressure refrigerant enters evaporator, liquid refrigerant will evaporate at high temperature. At what is the temperature at which a liquid will evaporate? It depends on the pressure at which it is kept. At high pressure, liquid will boil or evaporate at high temperature. Remember, Boyle's law, Charles law. If refrigerant is a lower pressure, refrigerant liquid, it will evaporate at a lower temperature. But we need a lower temperature. So we need to lower the pressure. Condenser pressure high is liquid pressure is high. That means refrigerant in the liquid form, pressure is high in the condenser. That we have to reduce it. We reduce it using expansion valve. And this liquid at a low pressure enters the evaporator. So expansion valve reduces the pressure of the high pressure liquid refrigerant to low pressure liquid. It also acts as a metering device and ensuring only that much amount of liquid is sent which will evaporate. If it's sent too much liquid, it will not evaporate, all of it will not evaporate. Alright, and the liquid will enter to the compressor. These compressors cannot handle liquid. They are designed to work only for gases. So will damage the compressor. So how does it meters the amount of refrigerant liquid being sent to the evaporator? It does so by measuring the superheat of the refrigerant gas. This is a little I will be covering in separate more chapters because it needs explanation. What is the superheater now? So for the time being, remember that it controls the amount of liquid which is going to the evaporator. As I said, caution: if too much liquid refrigerant is sent, some of it still in a liquid stage will enter compressor, damaging it. So again, I say compressor is not a pump; it's a compressor. It will handle only the vapors, gaseous. Thermostatic expansion valve. Hmm. I will explain it some different chapter later on. The heat is absorbed by the liquid refrigerant as it enters the evaporator. Now, liquid is entering at a low temperature. liquid entering at a low pressure into the evaporator. Evaporator is placed in the, let's say, atmosphere compartment which is need to be cool for our house. Now liquid will now evaporate, which is a low pressure. And when it is evaporating, it will need to take, it needs heat to evaporate. It will take heat from the area, compartment, refrigeration compartment, or the your house. We need to be air conditioned or temperature lowered in the refrigerator compartment. So a blower generally blows the air over the evaporator coils, thus making cool air spread the coolness in the proposed area. That in your house. That's why you have a cool air. This cool air is coming after the flowing over the evaporator. So the evaporator coils are cooled. So this air gets cooled, and this cold air is entering into your house. So that's how your house gets cooler. Similarly, in the fridge compartment, similar phenomena taking place. There is also evaporator. The small blower is pumping the cool air, no, because the temperature of the air drops down as it passes over the evaporator coil and therefore able to maintain -8 degree Fahrenheit or 22 degrees centigrade minus in the freezer or 22, 23, 24 at home. Now, question for you. Why does refrigerant become liquid at ambient temperature in condenser and become vapor in evaporator, which is at a much lower temperature than condenser? You understood what is the question? Condenser is kept in the outside. Let's say outside temperature is now 35 degrees centigrade or 30 degrees centigrade. All right. Here now gas is refrigerant becoming liquid. But inside the house, temperature is, let's say, 24 degrees centigrade, 22 degrees centigrade. But here, the evaporator, the liquid in the evaporator, which is refrigerant, in the liquid form, is becoming gas. Why? I explained earlier. So you think about it, and if you're unable to find the answer, put a note, post it. I will answer you. Okay. Refrigeration and air conditioning. Direction of the flow of refrigerant in a cycle. So, what is the direction in the flow? Compressor. From the compressor to the evaporator. From the evaporator, sorry, again, repeat. Compressor to the condenser. From the condenser, only vapor, that is refrigerant gases enter condenser. What comes out is the liquid, refrigerant liquid at high pressure. It enters the restriction or expansion valve. What is entering into the expansion valve? Refrigerant liquid at high pressure. What comes out? Refrigerant liquid at low pressure. What is entering? Now entering evaporator. What enters the evaporator? Liquid, refrigerant liquid, and low pressure enters. What comes out from the evaporator? Vapors at low pressure comes out and enters the compressor. So this is the cycle. Hmm. Again, for simplicity, receiver is not shown. Refrigeration and air conditioning. No. Again, this is the cycle. The transfer of heat energy. Heat is absorbed by the evaporator. Remember, heat is absorbed by the evaporator. Heat is absorbed by the evaporator and rejected by the condenser. So the red line is vapor line, gaseous form. Hmm. Whatever is shown in the right is gas. Compressor pumping gas entering to the condenser becomes liquid, high pressure. Coming to the expansion valve, liquid form. Comes out liquid, low pressure. Entering to evaporator, liquid form, low pressure. This is the evaporator. This is your room. This is a house, or this is your refrigerant compartment. Blower take the heat away, make the room cooler. Refrigerant becomes gas, enter the compressor. Compressor compresses it, raises the pressure. So the heat is now in the refrigerant vapors. It vapors enter the condenser, it gets cooled, become liquid, heat is ejected to the atmosphere, ambient temperature. All right. Just a question: at what temperature no heat is present? No heat energy is present. Hmm? Can you tell me? At what temperature no heat is present? You, you know absolute temperature? Yes, correct. Any questions so far? Post any question if you have. Now, by dividing the system vertically, if you divide the system vertically, as I have shown here, hmm, left, so the we become left and right. Right side is the high pressure side, correct? Left side is low pressure side. Refrigerant is a low pressure. That means after the expansion valve, evaporator, and up to the suction of the compressor is refrigerant is a low pressure, but partially liquid, partially at vapor or gaseous form. Right side, we have high pressure side, gaseous form before the condenser, after the condenser liquid, but always at this is at high pressure. All right, correct? No. In this case, dividing the system horizontally. What we are dividing? Upper side is gaseous form, lower side is liquid form. By dividing the system horizontally, as shown, we can see that all points above the line, the refrigerant is in a gaseous form, and all points below the refrigerant line is liquid. In the middle of both the condenser and evaporator, where the change of state of the refrigerant happens, the refrigerant is present in both liquid and gaseous states. You can say call it vapor. Correct? No? Is it clear? Now, did you notice in this complete air conditioning and refrigeration cycle, we have introduced three new terms: superheat, saturated, and subcooled. What are they? What is the meaning of this term? So here, gas enters or vapors enter or gas enter into the compressor, low pressure superheated gas. What comes out is high pressure superheated gas. It enters the condenser, it becomes high pressure but saturated vapor because partially liquid, partially gas. But what comes out is high pressure subcooled liquid, undercooling also called. That from expansion valve comes out, but now it is in the low pressure subcooled liquid form. Now enter the evaporator. It is what enter as a low pressure subcooled liquid, but then it turns into low pressure saturated vapor. Some liquid, some vapor. But eventually what comes out, enter to the compressor, it is low pressure superheated gas. I am not going to explain what is superheated, saturated, subcooled, because this will I'll be covering as further we go in the air conditioning modules. There will be some more modules coming. There I will be discussing this. Okay. So briefly I will explain. Superheat is an amount of heat added to refrigerant vapor beyond its boiling point. This ensures the refrigerant is in gas state with no liquid present. Saturated is when the refrigerant is a vapor with both liquid and gas present. Where in the system these three states are present. You can check and go back and see again. Subcooling or undercooling is an amount of heat removed from the refrigerant below its condensing point to cool it further below. It is condenses but continue to cool it. That is undercooling. This ensures that refrigerant is in a liquid state with no gas present, no vapor present. That is the purpose. Superheat ensure no liquid makes its way back to the compressor. Although we say compressor, it acts like a pump, which I said. But truly speaking, it isn't a pump. Pump usually moves liquid by way of an impeller. Whereas the compressors, as the name suggests, compress the volume of the gas, which raises both its temperature and pressure. Liquids can't be compressed, and any liquid making its way back to the compressor can cause serious damage. That's why no liquid refrigerant should enter the compressor, air conditioning or refrigerant compressor. It will damage the compressor. Subcooling is important as it ensures only pure liquid makes its way to the expansion valve, a kind of metering device, because it allows the quantity of liquid which is required, no more, no less. This maximizes the capacity, efficiency, and reliability of the system. So the refrigerant cycle, let's have a look at it. The compressor compresses the gas, changing it to a high pressure superheated gas. All right. Then it enters the condenser. Inside the condenser, the gas begins to cool and change state to a liquid. Additional cooling inside the condenser causes the refrigerant vapor to condense it further, making it, you can call it subcooled liquid or undercooled liquid. From the condenser, liquid refrigerant passes into the receiver, which acts as a storage tank and ensure no vapor pass to expansion valve. Expansion valve only liquid should pass through. As the high pressure liquid refrigerant passes through the metering device or expansion valve, it enters a low pressure environment, causing some liquid refrigerant to flash off into vapor. Remember nozzle on an aerosol spray. Inside the liquid, the moment you press it, what comes out is vapor. Some liquid droplets also. Exactly thing is happening here. So a small restriction, expansion valve, liquid is passing high pressure. What comes out on the other side is actually should be liquid, but some vapors is also present. So refrigerant liquid with very few vapor enter the evaporator where it absorbs heat from the space being cooled, causing the refrigerant to boil. As it continues through the evaporator coil, the vapor is superheated, turning the refrigerant to gas before it enters the compressor and starts the cycle all over again. Okay, this is the same thing which is being represented in a photographically. Compressor compresses the gas, changing it to high pressure superheated gas. Inside the condenser, the gas begins to cool and change state to liquid. Adding cooling inside the condenser causes the refrigerant vapors to condense to high pressure undercooled liquid, subcooled liquid. As a high pressure liquid refrigerant passes through the metering device, that is expansion valve, it enters a low pressure environment, causing some liquid refrigerant to flash off into vapor. The refrigerant liquid enters the evaporator, where it absorbs heat, causing the refrigerant to boil. As it continues through the evaporator coil, the vapor is superheated, turning the refrigerant to gas before it enters the compressor and starts the cycle all over again. Same is represented in photographically here. All right. This is just for your information. You're welcome if you want to contribute anything. Troubleshooting. Sometimes things may go wrong. What are the problems we may face? Let us see. Low pressure cutout is stopping the compressor. There, of course, there are safety cutouts and all. One of them is low pressure cutout. So what if compressor is cutting out again and again? Check that all the suction line valves are in open condition. Refrigeration is properly charged. Maybe liquid amount of not less. Check the receiver. Low pressure cutout is not effective. Defective oil pressure cutout causing compressors to cut out. Check for proper functioning of the oil pressure cutout. Replace it if it's defective. Ensure sufficient oil level is seen in the side glass. Motor overload cutouts are activating, stopping the compressor. Hmm. Ensure that the electric motor trips are working properly. Check motor is not drawing over current for whatever reason and is being tripped by safety circuit. Wrong setting of cutouts, it may cause the high pressure cutout is set too low or low pressure cutout is set too high. Check and change the settings. Clock filters, compressor powder with a filter in the suction line. If that is clogged, it will lead to frequent LP cutout. Check and clean the suction filter. Remember, all filters need to be cleaned as a routine, maybe weekly routine or fortnightly, whatever your ship decides. Defective condenser blower fan motor runs and stops intermittently. Check the motor capacity wiring. If condenser blown, fan is not running. If it's single phase motor is talking about. On ships, we don't use single phase, we use only three phase motors. Function of a compressor in a refrigeration system is to act as a pump to circulate the refrigerant in the cooling circuit. It can happen that to maintain the cooling temperature in the room, the compressor is running continuously. If this happens, following can be cause for the same: insufficient refrigerant, not able to provide cooling through the for evaporator through reservoir shows adequate level. Check that the thermostatic expansion valve is working properly. Maybe not working properly. Is not sending sufficient amount of refrigeration amount, refrigerant amount. Refrigerant charge is too low. Check for leakage. Charge the refrigerant. Remember, refrigerant can be charged as a liquid or a vapor, but only at the suitable point. There are certain point given for charging. Some place, some charging point you can charge refrigerant, vapor in gas form. Some places you can charge it at liquid form. So don't make a mistake. It may happen that all provisional rooms or cargo holds are maintained at correct temperature, but in doing so, the discharge temperature of the compressor is going above the limit. Correct? No. High compressor discharge pressure, excessive high suction temperature due to less refrigerant is possible. Recharge the circuit to maintain refrigerant quantity. Ensure TE thermostatic expansion valve is set properly and supplying enough amount to the evaporator. Insufficient cooling because of high seawater temperature or choked cooler or broken fins of the blower. Supply more water. Clean cooler. Check the proper functioning of the oil pressure cutout and replace it defective. Check out the broken fins of the blower fan. Common maintenance procedures. Another common problem with the first system is icing of the evaporation coil, which may happen due to too low temperature setting. Increase the coil temperature by adjusting TEV, thermostatic expansion valve, thermostated correctly, inadequate coil capacity. Possible design fault. Install large capacity evaporator coils. Defect, defrost cycle defective. Set it correctly. Let us see what did we discuss today. Kind of recap. Discuss common components of refrigeration and air conditioning system, requirement of those components in the system, and functioning, what each component do in the system, and why it is required, what function it carries out, commonalities, similarities in both the system, abnormal conditions and troubleshooting. Okay, did we achieve our goal? Let us see. If you have any question, you can write it down, post it on the channel, and now let's see how much we have learned. Question for you. You go through them, answer them. If you can answer, well and good. If you cannot answer or have a question, ask me, post it on the channel, and I will answer. All right, for you. I hope you enjoyed the course. Give your feedback. Appreciation will make us feel good and constructive. Positive criticism shall give us opportunity to learn from our mistake, if any. Otherwise, it's a win-win situation. Okay. Have a good day. Thank you very much.